Here's a video going over the Algebra 2 Unit 1 sequences review. I'm not going to do every question, especially on this first page, just because they are kind of repetitive, but I will do a few from each one. So with arithmetic sequences, remember that's where it's either adding something or technically subtracting if it's adding a negative thing. And so that's the rate of change, is that number that's adding each time. In this first case where it goes from -3 to -2, that is adding 1. So our next value will be -1 because that's -2 plus 1 and 0. The next one, from 13 to 25, that is adding 12. So subtracting 12 from 13, we would get 1 because 1 plus 12 will give us 13. And then from 25, we'd get 37 and then 49. The last one, I'll skip C. You can figure that one out on your own as a challenge for you. We know that there's 4 gaps in between here. And the difference from 92 to 80 is a -12. And since there's 4 gaps, it'll be subtracting 3 each time. And you can just check that with 89 to 86 to 83, and it does work out. So the rate of change for that one is a -3, and I'm going to write all of those right here. So this is a +1 or a +1, 12. You can figure out C on your own, and a -3 for D. Number 2, find the next 2 terms if it's arithmetic. So if it's arithmetic, right here from 1 to 10, it's got to be adding 9 to be arithmetic. So then it'll be 19 to 28. Geometric, that's when we're multiplying or dividing, which is multiplying by a fraction. Here we would be multiplying by 10 to get from 1 to 10. So the next one would be 100, and then the next one would be 1,000. And then it would keep going from there, even though there's a period. Okay, for 3, these are geometric sequences. So geometric is multiplying or dividing by, or multiplying by a fraction. So stating the growth factor. So on A, to get from 5 to 25, that's multiplying by 5. So to undo that, to go backwards from 5, we'd be dividing by 5, which 5 divided by 5 is going to give us 1, because we know that 1 times 5 will give us 5. And then 25 times 5 is going to give us 125. So the growth factor is 5. With B, something we should notice here is 216 is positive. So this has got to be multiplying by a negative to make it switch from positive to negative each time. So we know it's going to be multiplying by a negative. To get from 1 to something to 36, we know that 216 to 36 has got to be multiplying by a 6. And in this case, it's going to be a -6. So -1 times -6 is going to give us a +6, which then will go to -36, which then will go to -1,296. And I will do C, and then you can have D and E on your own. To get from 10 to 5, that's multiplying by a half or dividing by 2. So we'll keep doing that. State your growth factor, though, in the fraction form or the multiplication form. So 1/2 for this case. 10 to 5, then 2.5. If we divide that by 2 or multiply by 1/2, and then it'll be 1.25. And then you can do D and E on your own. Jada and Mai are trying to decide what type of sequence this could be. One thing to notice on this one is these terms skip. So technically we could recreate this table and with the term number or n and f of n or the value. 1, 2, 3, 4, 5. We know that 2 is the first one, 6 is the second one, 3 and 4 are skipped, and then 18. So the way it's written out in the original table, it looks geometric because it's multiplying by 3, but because it skips term numbers, it's actually arithmetic. and it's adding 4 each time. So you can explain that or look at the key to see an explanation of why that would work. Number 5, we have these two sequences, A and B, and it is squished, but it's fine. Writing out the table, we can see that sequence A, that's the blue triangles, starts at -1 when x equals 0. But when we have 1 for the term number, it's 2, and then it's 5, 8, 11, 14, 17. So this is adding 3 each time. So you can say starting at -1, add 3 to the previous value or previous term. With B, this one looks geometric because of that curved shape. It starts out at 1/2, and then it goes to 1, then to 2, then to 4, 8, 16, 32. So for C, sequence B, a way to describe from the previous term starting at 1/2, we always have to stay where we're starting at, not add. We are multiplying the previous term by 2 or doubling. And because sequence B is multiplying by something, sequence B has a growth factor of 2. Sequence A has a rate of change, so sequence B is the geometric one. Rate of change goes to arithmetic sequences. Okay, number 4. I'm going to do the first couple terms of each one, but then you can finish it out. So f of 3, we would take the function f of x, do 2, replace the x with a 3, minus 7. Make sure you do your multiplication, or in the next one you'll have exponents, before you add and subtract things. So this is 6 minus 7, which is a -1. F of 2, you'd work the same way. 2, replace the x with a 2, minus 7. So now we have 4 minus 7, which equals -3. And you can kind of see how the sequence or function works from there for each step. For g, this one's g of x equals 5 to the x. G of 3 equals 5 to the 3rd power. And if you type that in a calculator, it's 125, or if you just calculate it because you're smart like that. Five squared is going to give you 25. Make sure you do the following ones on each one. F of 1, G of 1, F of 0, yeah, all those. Okay, define the sequence W so that W of n is the number of white squares in step n. Okay, counting the squares. How many squares are there? I think we start out with 10, 14 to 18. So in this case, we are adding 4 squares each time. That means it's arithmetic. We know this because it is adding 4 white squares each time, or each step. 4 is the rate of change. It's always good to use the vocabulary from the unit. So rate of change, growth factor, things like that. Recursive. That means recursive means we're using the notation of the term before. And for recursive, we need three things. We need where we're starting at. So we are starting at step 1. So W of 1 is equal to 10 squares. That tells us starting at 10 squares with step 1, we know that each new value is going to be the value from before. So that W of n minus 1. And we're going to add 4 squares to each value from before. And we're going to do this starting with step 2, because we already know what step 1 is. So starting with step 2, we'll do that. And for the nth term, this is we can know any step based on the step before it. Since it's arithmetic, we're going to add 4. And we have to do that to each step minus 1. And you can plug in a number to make sure it works. And that's going to be for starting at step 1. Just a side note, this is also equivalent to 10 plus 4n minus 4, if we distribute that 4 in there, which is also equivalent to 6 plus 4n. So those are technically the same thing. For n equals, n is greater than or equal to 1. Don't know if I said it like that before. Okay, this is just an optional thing, but it's just a good way to check to make sure that your nth term is correct. If I plug in step 3, I should be able to get 18 out of it. If I do not, then something's wrong. So I'm going to go back to my original one that I have. W of 3 equals 10 plus 4 times n, which is now a 3 because it's step 3 minus 1. This gives me 10 plus 4 times 2, which gives me 10 plus 8, which is 18. So it does work. Okay, last one. Below is a graph of sequence M. Write a table for M. So starting with step 1, it looks like. And even though it's not graphed, this does keep going all the way because it's a sequence, and right now we don't have it as a situation. So step 1 is at 7, step 2 is at 5, 3, 2, 1, negative 1. Okay, there's a table for the sequence of M. Defining it recursively. So we know that it starts at step 1, and that is 7. And then each new step is going to be the one before it. So m of n minus 1. And we're going to subtract 2 each time. That's the the rate of change. A minus 2 or negative 2. And this is going to be, since we started with step 1, the next step that we're going to go to is step 2. And nth term, m of n is going to be our starting place minus 2 times our n minus 1. And that's starting for our step 1. And it does say to simplify this equation, which it can be simplified. So 7 minus 2 times n minus 1. We're going to take that minus 2 or negative 2 and multiply it by each thing in the parentheses or distribute it. So we'll have minus 2n plus 2, which this is really 9 minus 2n for n is greater than or equal to 1. We can't combine that 9 minus 2n because it has an n2 in it. It's not a common factor. But this is the same equivalent form, simplified. And there you have it. There is the Unit 1 study.